So we are recapping the entire unit on exponents real fast. Let's see what you remember. What do I do when I want to multiply two numbers that have the same base but different exponents? You add those exponents together. So that ends up with x to the 7th. I can almost guarantee you, if that's a question on your final exam, one choice will be x to the 7th and one choice will be x to the 12th. So make sure you remember. And if you forget, take a minute and step back and say to yourself, okay, well, what is x to the 3rd really? Isn't it x times x times x? And then isn't that x times x times x times x? And you're like, oh yeah, that's just x to the 7th. So you can reason your way back here if you need to. Hopefully, right? When is it that I multiply them? Correct. If I had x to the 3rd and then I raised it to the 4th power, for example, that's when you multiply. You have to raise a power to a power. Okay? We also had, if you have more than one thing in parentheses, so if I had like 2x to the 3rd and I raised it to the 2nd power, what happens? Right, everybody in those parentheses gets raised to that power. So now it's 4x to the 6th. Remember that? And then things start going crazy when you start introducing division and negative exponents. Okay? That was probably the hardest part of this whole chapter. So here's the thing. If I have x to the 5th over x to the 3rd, what do I end up with?
X to the 2nd.
Yes, x to the 2nd. So you are doing 5 minus 3, and I end up with x squared. Me personally, I don't like thinking about it as subtraction because it gets all weird and confusing. Because if I switch them, if I have x to the 3rd over x to the 5th, what does that end up being?
1 over x to the 2nd.
Yeah, it is 1 over x to the 2nd, and that's where you need to end up. But if you are just strictly doing the subtraction, you're going to say x to the negative 2, but then you have to rewrite that because we're never allowed to have negative exponents in our answer. Thank you. Unless you happen to be writing your answer in scientific notation, but that's not what this is. So I don't even like to go to this spot. I go right to 1 over x squared. They are the same thing, but I'm telling you, it is so much easier to wrap your mind around it. I had 3 on the top and 5 on the bottom. Watch, I'll even draw it. 3 on the top and 5 on the bottom. If I cancel them out, I'm left with x squared on the bottom. Easier to think about that because when I have negative exponents, remember they all move and it's all crazy. So let's try one with negative exponents in there and see how we handle it. Okay, say I had 4x to the negative 3rd y over x squared y to the 4th. Say I had something like this, right? The first thing I need to remind you of is that everybody's kind of separate. You're going to handle the numbers, then you're going to handle the x's, then you're going to handle the y's. That 4 isn't tied into anything else unless you saw a plus or minus some other value. Oh boy, okay. So I ask you, what is happening with this 4? Nothing. It's going to stay exactly where it is. What is happening with this x to the negative 3? It's going to move downstairs. So I'll even see if this shows up. This is now going to move down into the denominator. So now I'll have x to the 3rd in the denominator. What happens with this y right here? Well, I will cancel it. It's not being raised to a negative exponent though, so for now I'm just going to leave it where it is, and then I still have that x squared y to the 4th. Okay, now there's still more for me to do. There's no other numbers to do anything with that 4 with, so I can't cancel that 4, reduce it, nothing like that. Okay? Let's look at the x's. What do you have in total? X to the correct, and it's just going to stay on the bottom. Now, the y's, you have one y on top and four y's on the bottom, so when you cancel them, you'll be left with y to the third on the, and this is why I don't deal in subtraction. Because if you do 1 minus 4, yes, that's negative 3, but then kids always mess up, where do I put y to the negative third? It would always go in the numerator, by the way, but then you'd have to drop it to the denominator anyway. It's too confusing. There's too many chances for error, in my opinion. Just think about it. I have 1 on top, 4 on the bottom. That means 3 left on the bottom. Okay, let's sort of put some of these together. What if I had 4x squared y to the 0, and then I was going to raise that to the negative second power, and all of that was over 8x to the negative third. Let's just do that. Okay. What are you doing? Where do you even start? You could. Is there anything that, and that's another thing, is that there's not necessarily a right or wrong way to start these. You have to apply all of the rules that we talked about up here, but you don't have to do them in a specific order. So you can do what you want first. I usually like to, well, I can't reduce 4 and 8 yet because that 4 is being raised to a negative 2 power. So the one thing that jumps out at me personally is that y to the 0. What's y to the 0? What do I do with that? Those are just ones, right? Anything to the 0 power is 1. So I can ignore this. And now my life just got so much easier because I don't have y's now at all. And then I would say let's go ahead and give everybody that negative 2 exponent. So now we won't have parentheses anymore. So I'll have 4 to the negative 2, x to the negative 4, all over 8x to the negative 3. The next thing I would recommend doing, move everybody with a negative exponent. Move them around. Before I start canceling anything out, let's move them and then I'll assess. So, what happens with this 4 to the negative 2? Goes down. If they have a negative exponent, anything with a negative exponent moves. Yep. So now this becomes 4 squared in the denominator. Right? When you move it, now it doesn't have the negative exponent anymore. It's just the positive exponent, whatever it is. X to the negative 4th, gonna go down. And now it becomes x to the positive 4th. What happens with that 8 right there? He stays. It's gonna stay right in the denominator. And what happens with this? Goes up and is now x to the positive 3rd. Now I'm ready to attend to this. So let's see. I always deal with now that I've done everything, I took care of all the negatives, I don't have any powers of powers to worry about. I'm going to start off with the numbers. I have 4 squared on the bottom, or 16, times 8. That's all staying in the denominator. So whatever 16 times 8 is, 128. That's just in my denominator, 128. But now let's look at the x's. What would I have for the x's?
You have x on the bottom.
X to the first on the bottom, correct.
And then you got the
Exactly. I can guarantee you, if you're looking at the choices, I bet you anything, one of the answers will be the right one, 1 over 128x. But they're also going to have a choice B that's just 128x. And that is 100% wrong, because that's in the denominator. There's a 1 up there. If everything's gone, it's a 1 that's up there. You can't just ignore it and just say, oh, it's all of a sudden 128x. No, it's not. It's in the denominator. It's a big difference. You with me? Okay. I'm going to have you try a bunch on the board, but I think let me do one more. that we kind of walked through. What if I had something like 2x times 3x squared y to the negative 1 squared over 12x to the 4th. Something like this. You have so many options for where to begin. Do you want to try it? Okay, try it. See what we end up with. Okay, so I'm going to start off by squaring everything in this parenthesis. That's what I would do first. You didn't have to do that first. Maybe you reduce the 2 and the 12 first. I don't know. I am going to do this. 2x, and then everything in there is getting squared. So that's now 9x to the 4th, y to the negative 2. Downstairs, I'll just recopy it. Okay, now I'm going to handle the numbers. So up top I have 18, and on the bottom I have 12. Can I reduce them? Yeah, so that's now reduced by what, 6? So that'd be 3 halves. Okay, then I'm going to look at the x's. I have 5 x's all together on top. Well, look, isn't that even easier? Cross off those x to the 4th because they match, and then I just have x left on top. Even easier to think about that. Same thing with the y's to the negative 2's. Oh, got lucky there. They're the same, so I can just cancel them. So my final answer, 3x over 2. Did you get it? Oh, yay. All right, so that's the gist on the properties of exponents. Now, also in this unit was scientific notation. So, a couple things about scientific notation. First of all, if you are given choices on a final exam and they look like the following. Let's just pretend that you got those 4 choices and you're supposed to be writing your answer in proper scientific notation. You can already cross off 2 of these right away. C. Why? Yes, that number is supposed to be between 1 and 10. So, for the same reason, I can get rid of D. So, use that fact to your advantage. If that's the instructions, right? Write your answer in scientific notation. These are not scientific notation, so they can't be the right answer.
A's going too because it can be negative, right?
They can. Yeah. Scientific notation, you can have negative exponents or a negative number out here. Yeah. Yeah. So, I said between 1 and 10. Yeah. So, yeah, that's misleading. It could be between positive 10 and negative 10. I mean, you know what I mean. Yeah. Between 1 and 10, positive or negative. Okay, so then I would obviously have to do the math and figure out which one of these 2 it is, but that's the gist. So let's try one. Say I asked you to do something like oh, I don't know, 4.7 times 10 to the 5th, and you were going to multiply that by, I don't know, 2.3 times 10 to the 12th. So you had something like this. Well, I forget what calculator you're allowed. I don't know if you get these yellow ones or if it has to be one of these blue ones. Let's assume that it's a blue one. So the blue ones don't do exponents. They're just these called 4-function calculators that just do your basic add, subtract, multiply, divide, square roots. That's about all you get. So assuming you only have access to this, which I'll double check and see which one you get. Okay, so if I have to do this, does anybody remember how you start?
It's like the full kind of.
Well, it's all multiplication here, right? All 4 of these numbers are getting multiplied together. That times that, and then that means multiplication there. So it's all multiplication. So you can actually ignore the parentheses. They really mean nothing here. What I would do is start by multiplying the 4.7 and the 2.3. Let's see what that gets me. 4.7 times 2.3 is 10.81. And then if I multiply 10 to the 5th times 10 to the 12th, that would get me 10 to the, close. 5 and 12 gets me 17.
Oh, yes.
But now, if you pick that as your answer, you're probably getting it wrong. Because that is not in scientific notation because that's too big. Right? So we got to fix it. So that would, remember we talked about this? That was going to turn into 1.081, but now it's times 10 to the 16th. So, oh, wait, sorry, 18th was right. Sorry. So, remember how we do this. So you ignore that for a second. Ignore the times 10 to the 17th. I just want to write 10.81 in scientific notation. Remember we talked about the difference between if it was going to be a positive exponent or a negative exponent, and I tried to use the example of money. If it's more than $1, you find more than $1. You're excited about that. You're like, yes, that's positive. If it's less than $1, I'm really not enthused. I mean, I am, but we're imagining this, right? Like if I find 0.02 of a cent, I really don't care. That would be negative, okay? So if my value, which is $10.81, you better believe I'm excited about finding $10.81. So that would get me a positive. And I only had to move the decimal 1 place, so that's 10 to the 1st. And then I still have this time 10 to the 17th. So now altogether I have 1.081 times 10 to the 18th. Okay, let's try one more. Let's do maybe a division problem. Say I had, I don't know, 0.03 times 10 to the -3rd and 15 times 10 to the -9th. I don't know. And you are asked to do this math and get your answer in scientific notation. So, first thing you got to do, divide those two. So 0.03 divided by 15 gets me 0.002. Okay, now let's deal with the tens. What would I get if I had 10 to the -3rd and 10 to the -9th? Where's that going to leave you? 10 to the... Well, think about what's happening. This guy would move downstairs, right? So I'll write it. Yes, he's going to move downstairs. He's going to move upstairs. So now I have 9 over 3. So there's 9 on top, 3 on the bottom, which means I have 10 to the 6th on top. Scientific notation is the only time where if my exponent right here was a negative, I wouldn't have to rewrite it.
What about if there was like a larger exponent, like in the 10 on the bottom?
Yes, okay, so if it was the other way around, let's just say it was, let's say it was 10 to the 3rd over 10 to the 9th. Then you would write it as whatever this number is times 10 to the -6th. And you don't put it downstairs only when you're writing a number in scientific notation. Otherwise, we're not allowed to have negatives in our exponents. Okay, so we're here. You pick this, you're getting that answer wrong because that's not scientific notation, right? So we got to say to ourselves, okay, ignore that 10 to the 6th for a minute. You have to move that decimal 3 places to turn that into a 2, because remember, my goal is to get a number between 1 and 10. So 2, ignore that 10 to the 6th. That would be 10 to the, now ask yourself, okay, 0.002, you find that kind of money. Is it positive or negative? It's negative. Ugh, who wants to be bothered with 2/100ths of a penny? Who cares, right? So that would be a -2. And then I still have this times 10 to the 6th. So my correct final answer, when I put it all together, 2 times 10 to the 4th. Oh, I'm sorry, it was supposed to be 3. I just messed up. So that would make this a 3. I kept looking at this too. Thank you. All right. So that was scientific notation, and then the rest of this stuff is not so bad. You do need to remember the names though of the polynomials. Do you remember? I don't know. We'll make a little chart. Let's do named by degree. So we can name polynomials by degree. The smallest degree you can have is actually 0. And you got 1, 2, 3, 4. I think we went all the way up to 5. Yep. So if a polynomial has degree 0, which basically, guys, remember, if a variable has an exponent of 0, so let's just do an example. If I had 2x to the 0 power, doesn't the x just go away? Right? Yes, and that's why it's a constant, because there is no variable. Remember, the word variable means varies. It can change. But if I don't have a variable at all, it's not changing, it's constant. That's why that's called constant. It's not going to change because I don't have a variable. If I do have a variable to the first power, it's called a linear. If I have a variable squared, it's quadratic. To the third, cubic. Fourth was quartic, like 4 quarts in a gallon. And then 5 was quintic, like quintuplets. We'll do some examples in a minute. So that's naming it by degree. And then you also have to name polynomials by number of terms. These ones are a little bit easier. You can't have 0 terms because then you don't have a polynomial at all. So you have to have at least 1 term. And if I have a 1-term polynomial, it's called a monomial. 2 was a binomial. And 3 was a correct. If it's any more than that, then we would just say a 7-term polynomial, a 25-term polynomial, whatever it is. But those are the only 3 that you need to know. Okay? So then we might put this together. I might say, okay, what is this thing? You should be able to name it by degree and by number of terms. Correct. This would be a cubic binomial. Make sure that before you name it, that this is fully simplified. Like if there's math for me to do here, I should do it first, and then I would classify. Okay, so for example, if you had this, x times 4x minus 3. Well, you can't do it yet until you distribute that x. So distribute that x, and then you can classify. So when you multiply that x through, what do you get? Right, and now you can call this thing a quadratic binomial. Exactly. So do the math first, then classify. Okay? And then really the rest of this chapter was just doing operations with polynomials. So for example, you might have 2x to the third minus x plus 1, and then I might ask you to add that to 5x squared minus 2x plus 3. Something like that. Are you trying it?
Which one are we trying?
Right here. Add those two together. Okay, if you combined like terms, I hope you got 2x to the third plus 5x squared, and then I have a negative x and a negative 2x that will come together to get a negative 3x, and then plus 4. Oh, is that what you got? Now I want you to do the same problem, but subtract. When you have a subtraction problem, the most common mistake is to not subtract properly. You have to distribute that negative to everybody. So now it's really a minus 5x squared plus 2x minus 3. And now I want to combine like terms. Very often kids only subtract the 5x squared, not the rest of it. That's totally wrong. You have to subtract everybody. So your final answer should have been 2x to the third minus 5x squared plus x minus 2. You got it? Phew. Also in this was FOIL. So, I mean, I think we're pretty good at FOIL now, I hope. So if I asked you to do that.
Wait, but then what would their like degrees and terms be? 'Cause I get confused on that.
Oh, okay. So if you wanted to name this thing by degree and term,
Yeah.
so what is its degree?
You can go by the biggest one.
Yeah, so
That'd be
it's,
a cubic.
right. So the highest exponent I have in the whole thing is 3. So that's what counts. So it'd be a cubic, and then how many terms are there in this?
3.
You sure?
I don't know. That's quite different.
So I think of terms like chunks of numbers. 1, 2, 3, 4.
Oh, so what would the fourth term be? 'Cause you only have 4 listed. You only have 3 listed up there. Like all.
Oh, you'd just call it a 4-term polynomial.
Okay.
So if it's anything more than 3, you just say 4-term, 5-term, however many. Yep. So that would be a cubic 4-term polynomial. All right. Now you might have something like this where you have to FOIL these together, but this is old news. You guys have been foiling for ages. I'm going to give you one more where I'm trying to trick you. Okay, you FOILed this one together? What do you get? X squared, then what?
Minus 4x. Well, the answer is. You want the answer like doing
I don't know. I guess I'll write out the FOIL. Since it is a review. Yeah, so remember, FOIL stands for first, outers, inners, last. So first you get x squared. Outers, what do you get?
Minus 7x.
Inners.
They're plus 3x.
And last.
Minus 1.
Right, so those should have been the pieces that you got, but then you have to combine like terms. So that's how we end up here. So hopefully everybody FOILed there, nice and easy. And then I want you to do this one, and I gave you 4 choices. So x minus 2, the whole thing squared. Which of these 4 does that come out to be? Hopefully, since this final exam is multiple choice, hopefully if I hadn't given you choices and I had just asked you at the start of class what that was, I bet you about half of you probably would have told me it was B.
So it's not B.
It is not B.
Is it?
It is, no, it's not.
It's not?
Oh
wait, I meant C.
C I like a lot better. Oh dear. So, when you have x minus 2, a binomial, and you're squaring it, you have to do x minus 2 times x minus 2. You are not just pushing this squared to both of them. The only time you can do that is when everything in here is multiplication. That's when you can give everybody an exponent. This is not that. That's this. You have to FOIL that together. So when you do that...
It's like square root in a way, right? Well, not square root, but like you square it.
Right. So you're taking that binomial and you have to multiply it by itself 2 times. FOIL. So x squared minus 2x, and then plus a 4. So minus 2x and minus 2x again. That's how I end up at C for my right answer.
So you have to FOIL that.
Right. So if you're given the problem just like this, right, x minus 2 squared, I would recommend that you write it like that. So that, because when you see this, you know to FOIL. When you see just that, you think that you just square both of them and move along about your day. But that is not the case. If it's a binomial, you gotta FOIL them together. Be careful, okay? So that's pretty much it for Unit 10. Yeah.
If it was x plus 2 in the parentheses, would it look like x plus 2, x plus 2?
Yeah. Okay, any other questions for this unit right now? No? Okay, so let's stop this video. So that was all.